let's consider a problem in which we have a ladder put up against a wall. Okay, so let's say the ladder has a length here, L, of 3.3 meters. Okay, let's say it's leaning at an angle of 60 degrees. There's a coefficient of friction, mu sub s, of 0.4 between the bottom of the ladder and the wall. To make this easy, we're going to assume that the coefficient of friction is 0 at the top of the wall. That makes the math easier. And then we're going to say that the mass of the ladder is going to be 20 kilograms. Okay. And now we have a person starts climbing the ladder here. Okay, so the mass of the person, let's say, is 75 kilograms. The question is, how far up the ladder X can the person go before the bottom of the ladder slides out from under them? Okay, so what do? Free body diagram. We say, what are the forces acting on this? Well, we've got the mass of the ladder times G pulling down at the center point of the ladder. We also have mass of the person, G, pulling down at this distance of X from the end of the ladder. Okay. Now, force up has to equal force down, so there has to be a force up here, a normal force right here. I'm going to do Fn1, just for a second. I'll explain where Fn2 comes from. Okay, so there's the normal right there. And now we know that the bottom wants to slide this way. Therefore, there has to be a frictional force right here. So force of static friction. Now, since the ladder's not moving this way, there must also be a force in the other direction. That force is the force due to the wall up here. That's Fn2. Okay, so we have a lot of forces acting right here. And so we look at that and we say, well, what do we do? Well, we know, therefore, that Fn2 has to equal Fs. So force left equals force right. So Fn2 is pushing left, the frictional force is pushing to the right. Well, we know that the frictional force is going to be, the maximum frictional force is going to be mu sub s times the normal. Well, it's going to be Fn1, so it'll be the normal at that spot. So this is our force left equals force right equation. Now, and we just plugged in for what we know the frictional force is going to be. Now we want to do force up equals force down. Force up equals force down. So what is that going to do for us? Well, force up is going to be Fn1. Force down is going to be the mass of the person times G plus mlg. So that means that Fm1 is going to be mp plus mlg. So that means Fn2 is going to be mu sub s times mp plus mlg. Okay. So now we have Fn2. Okay. Well, now what we want to do is we say, okay, that didn't really helped us any. We still haven't figured out how far the person went. Okay. But at least we know what the forces are. Okay. So we then say, okay, so now what? Well, now what we're going to do is we're going to talk about torque. And now we want to say that clockwise torque equals counterclockwise torque. So clockwise torque equals the counterclockwise torque. So clockwise torque, what's pushing clockwise? Well, we got to pick a pivot point. So I'm going to put my pivot point right here at the bottom. So clockwise would be mass of the person G times X plus mLg times L over 2. Counter, well, no, it's not this. Why is it not that? Well, because of angles. Remember, torque equals R cross F. So the magnitude of that is going to be RF sine theta. Okay. So that makes it a little bit more complicated. So that means we need to know the angles. If this angle is 60 degrees, that means these angles are both 30 degrees, and this angle right there is 60 degrees. Okay. So now we are ready to do this. So the clockwise torque is the counterclockwise torque. So that means it's going to be mass of the ladder times G times L over 2 times sine 30 degrees plus mass of the person times G times X times sine 30 degrees. And that has to equal the Fn2 sine 60 degrees times L. Okay. But we know that Fn2 is going to be equal to mu sub s times the mass of the ladder plus the mass of the person times G times L times 60 degrees. So X, if we do some algebra here, X is now going to be mu sub s ml plus mp sine 60 degrees minus ml times 1/2 times sine 30 degrees times G times L divided by mass of the person G sine 30 degrees. And notice we can cancel the G's. Okay. So now we're able to plug in all the numbers, and what we come up with is 2.5 meters. So the person makes it up 2.5 meters before the bottom slides out and the thing goes crashing down on them. That's why ladder accidents happen fairly regularly, and that is that people tend to not be careful, and they'll put a ladder and they'll actually step on it, and they'll bounce up and down a little bit. It seems stable, and so they climb about 2/3 of the way up the ladder, and then whack. And then once it starts sliding, then this angle becomes shallower, and now the torques are bigger and the friction's less down here, and so it just accelerates downwards. And so frequently people end up getting hurt on ladders because they climb actually quite a long ways up before all of a sudden the bottom starts moving, and if it starts moving, it accelerates, and you don't have time to climb back down to achieve stability.